Okay, so welcome to a short video to take a look at how to solve the problem, what concentration of silver nitrate is needed to reduce the solubility of silver carbonate to 1.0 times 10 to the minus 8th molar. And we're given the KSP of silver carbonate of 1.5 times 10 to the minus 9th. Well, we're dealing with solubility and KSP, so we can write out the solubility product expression. Ag2CO3 solid makes 2Ag plus CO3 2 minus. And we try to visualize what's going on. So we have a solution where maybe we've got some silver carbonate that is a solid in equilibrium with some silver ions and some carbonate ions. And we also have a silver nitrate concentration. So in here we've got some silver nitrate, and the silver nitrate is of course going to consist of silver ions and nitrate ions. And the nitrate ions are not part of this equilibrium, so they're spectators. We don't really have to worry about them. But the silver ions, if we have some concentration of that, and we're trying to find that concentration, if we have some concentration of that, then it's going to reduce the solubility. We have an ion in common with the two ions in silver carbonate. And so that'll make the concentration less, and we can do our usual kind of ice table things where we can say, well, we have some concentration of silver ion from the silver nitrate. I don't know what it is. Let's just call it question mark. And we're going to pretend that none of the silver carbonate has dissolved yet. And then for it to dissolve, the reaction will go to the right a little bit, and that means that the silver ion concentration will go up by 2x, and the carbonate concentration will go up by x. And then at equilibrium, we have whatever the concentration is of silver ion in the silver nitrate, plus 2x. And then for carbonate, we have x. And now, we of course know that KSP is equal to the silver ion concentration squared times the carbonate ion concentration, and that equals 1.5 times 10 to the minus 9th. And let's see, we're trying to find this unknown concentration of silver ion, and we don't know that, and we also don't know x. Well, wait, maybe we do know x. Let's think about this a little bit. We want to reduce the solubility of the silver carbonate to 1 times 10 to the minus 8th molar. Well, whatever amount of silver carbonate we had that dissolves, it's going to make some carbonate ions and some silver ions in solution, and if x moles per liter of silver carbonate dissolves, it's going to make x moles per liter of silver carbonate and 2x moles per liter of the silver ion. And that x then represents the solubility of the silver carbonate, and we know that that's 1 times 10 to the minus 8th. So what this means is the silver ion concentration is going to be question mark plus 2 times 1 times 10 to the minus 8th. And then that whole thing gets squared. The CO3 2 minus concentration is 1 times 10 to the minus 8th, does not get squared, and that equals 1.5 times 10 to the minus 9th. And now notice x by comparison to 2 times 10 to the minus 8th, well, 2 times 10 to the minus 8th is probably very small compared to whatever this concentration is here, because the product's going to be a very small number. So probably this term is negligible. And we'll be able to see quickly if our assumption is good. So if that's negligible, it's essentially not counted. And so what that means is we have question mark squared times 1 times 10 to the minus 8th equals 1.5 times 10 to the minus 9th. And now to solve for question mark, let's divide both sides by 1 times 10 to the minus 8th. So question mark squared equals 1.5 times 10 to the minus 9th over 1 times 10 to the minus 8th. And then question mark will be 1.5 times 10 to the minus 9th over 1 times 10 to the minus 8th square rooted. And when you calculate that, you should see that this concentration is going to be pretty large, at least compared to the solubility, 1 times 10 to the minus 8th. So our assumption is good, and whatever value you come up with there is the solubility.